Welcome back to our panel discussion, Open for Business, the State of the Federal Cloud, sponsored by Dell and Red Hat, here on Federal News Radio 1500 AM and federalnewsradio.com. Our guests today are Tracy Pavillard, the Executive Director for Dell Federal, Nathan Jones, Vice President of Federal for Red Hat, Dr. Naveen Venbar, the Cloud Engineer and Director of the GSA IT Integrated Award Environment, Dave Mihalsic, the Chief Technology Officer at the Defense Information Systems Agency, and Charlie Bradley, Technical Director for the NSA's Technology Directorate. And let's kind of get back to the beginning of cloud. In many ways, the government still is at the beginning of cloud, and the knock on cloud, or the impediment to cloud, are two things. One, it's not as secure as the servers I love to hug, and the data center whose key I personally turn in the door every night. And of course, there are latency and network errors which make it slower, and the applications don't work so good. Okay, so true, false, or what's the story? We'll start with you, Dave.
Well, false, absolutely false. So once again, the answer to these questions is going to be it depends. With cloud, you can achieve equivalent or better security than you can with a traditional environment. So one of the things that we've done in support of the Department of Defense is define a cloud security model that lays out the standards both for commercial clouds the DoD is going to use, as well as for our internal private cloud. So we have a 6-level model, but we've tried to simplify that a little bit. So levels 1, 2, which now we just call level 2, are basically publicly releasable data, and we do have basic security criteria for those, but those can be satisfied in a fully public cloud. We partner with GSA. We start with their FedRAMP process. That's the point of entry, and then we do a DoD provisional authorization on top because GSA doesn't have as granular a set of standards as we do. So at the next level, levels 3, 4, once again, we've abbreviated that to now just level 4. That's sensitive but unclassified data. It could cover things like PII data. It could cover for official use only data. It could cover contract sensitive data, etc. That data can be processed in approved government clouds, so clouds that have been specifically formulated by the provider to serve government customers, federal, state, local, tribal, etc. There have been a number of those.
But not commercial also.
Right. So we're in there with just other government customers. They have to meet higher security criteria than the public cloud providers. And there are a number of those that have been approved through the GSA FedRAMP process and gotten through the DoD provisional authorization process. At the next level, we have level 5, which is unclassified but sensitive national security data. So our most sensitive unclassified data that might pertain to things like troop movements, etc., that must be processed in a cloud that only is accessible by other federal entities. So it can be a commercially provided cloud, but it's got to be dedicated to federal use.
So it's almost like a COCO, contractor-owned, contractor-operated, in effect.
Certainly. It could be provided by one of the many public or government cloud providers that we have today, but they've specifically oriented that to serving only federal customers. And then finally, at the higher levels, we have level 6, which is classified data, and that requires a physically isolated infrastructure, can't be connected to the internet, needs to be directly connected to the DoD's network. And even at the lower levels, we have a point of control for connecting public clouds at level 2, the government clouds at level 4, and the federal clouds at level 5 to the DoD network. It's something called a cloud access point, so it gives us a way to not only interconnect to those providers, but be able to control the flow of data between the cloud and the DoD network, isolate connections as required. For example, if there's a security compromise in that cloud provider, and likewise provide a point where we can decrypt data and provide security monitoring and feed data from that monitoring into our analytic cloud.
And so level 6, that's basically SIPRNet.
SIPRNet is one example. Certainly, there could be others, but we have a private cloud stood up called MilCloud that's on SIPRNet. It is basically a integration of commercial technologies that is operated by DISA. But moving forward, we envision an era where there could be private clouds connected to the DoD network that might be acquired as a managed service. A great example of that would be the CIA's C2S program, where they have a contract with a commercial cloud provider where they provide their infrastructure connected to the IC's network.
Okay, and from the civilian side, Naveen, you've got similar issues, security and performance.
Absolutely, and I think I'll take a slightly different tack. I love data, but let's talk about applications, right? So we also are leveraging that FedRAMP capability, obviously, but what's the direction that we're going, and we're starting down this path to define exactly how we want to create this architecture, right? But if we go back to that containerization idea, FedRAMP says you're secure up to so far, right? You're secure up to your IAS, and then you got to worry about what you have to do after that, right? If you take the containerization concept and define, well structured, well secured, containers, right? We've actually looked at those containers. They meet all of our security standards. If we start reusing those, well, that takes us a little further down that path, right? Of now I'm getting closer and closer to not having to worry about those elements of security as I build my application, right? Getting closer to that dream of automated security that Dave has mentioned, a few moments ago, right? Where you can say, hey, because you're using a, signed secure container on this secure cloud environment, you now only have to worry about the application logic end of the world for watching security, and we can start applying the tools there and start worrying about things at that level. And that's really the path that we're taking. And as we go forward with the GSA, we want to be a provider to the civilian agencies of those cloud services, right? Because we have the ability to sell some of those services, and partner with other agencies. And that's over the course of this next fiscal year, one of our big goals is to be able to do that and say, hey, here's a FedRAMP, platform capability that you can now use and actually launch your applications on and not have to worry about a whole slew of security controls.
But when you have containers and they're built with open source tools and so on, that implies that other people can work on them. And so how does the whole idea of version control and trusted gold copy and that kind of thing come into this object area or this container area when it is open source and it's out there freely for, say, other federal customers to change or modify? Sure.
So just because we're seeing people, propose changes, make changes, doesn't mean that we immediately pull them into our environment, right? So creating a process around, what do we consider golden, right? Whether it be a container or an image, or a virtual image, whatever it might be, is very key to keeping a secure environment going, right? But the other end of that is that if we've automated all those tests, right, and we've automated our security tests and our functional tests and everything that goes along with it, if we discover that, for example, we see that a container has a vulnerability that's been discovered, out in the public, and somebody out there in the open source world updates that definition for use, we can actually run that container, test those applications that are sitting on that container without anybody really having to intervene manually to actually see, does everything still work, right? And if it all still works, deploy it, and we're even more secure faster, right? We don't have that weeks and months that we have to go and, manually do our tests and manually, redeploy our applications, right? It's just there working.
And Nathan, I guess as a supplier of these open source tools, they are open source, so by nature, anyone can get them from any source. So what are some of the kinds of value-added products and services you need to wrap around them to enable this kind of control and use at a federal level where it does matter if it's modified?
Yeah, where we've seen the market go in terms of all of this open source innovation that happens out in communities, when customers go to bring that in-house and go to leverage that technology, you have to take a very disciplined security approach to it. So back even to the operating system example we talked about earlier, even some of the security credentials we built into the operating system over 12 years ago with the NSA are inherent now in the virtualization models that Red Hat supports, as well as the container support models that Red Hat supports. So going and downloading container tools from the internet is not a secure way to do it. Going to a vendor-supported enterprise distribution and getting that container support inherently allows you to build an architecture that it takes the new capability and supports it. But the things that you worried about at the operating system level in terms of driver support and interaction of different processes is amplified when you start to talk about the modularity of containers and also was existent in virtualization. So it's very, very important, even more important to make sure, and IT security folks and all these agencies are concerned about this, that the tools you bring in to build that private cloud are all credentialed, all have the right FIPS or Common Criteria certifications, so that you build that private cloud from the bottom up with open source capability, but with trusted source software and with credentialed software that you know what you're dealing with. So you're not just adopting something that is, the technology of the day that happens to come out on the internet. So I think that's the disciplined approach that certainly the federal government uses.
So an analogy might be the open public app stores versus a government-operated app site where you provision your mobile device from that place and not from, this market or that store.
Sure, knowing where you're getting your components from is absolutely essential. So having those marketplaces and those app stores, if you will, those types of environments built with trusted source software so that you know what you're dealing with is important. So open source is not all created equal. It's you need that enterprise vendor supported open source that's been vetted by the security folks and all these agencies. And once you build that platform and the developers use it, then you know that you have a very secure environment with which to put into production.
And Charlie, of course, security is the middle name of your agency. And so what's your approach to making sure that open source developed things that you might share in the IC or even beyond the IC retain that security that you intended it for in the beginning?
So with regard to the actual applications or the analytics, depending on what you're trying to do with that platform, I think all the previous panel members have made points about the development environment. To me, it kind of gets back to the point of there's got to be a framework for software assurance. And you may implement that differently in your organization, but at the end of the day, you have to have something. Because there's opportunities and risk in just going and pulling things off of the internet. You have to understand what that is, and you have to weigh those risk decisions for whatever your potential mission gain is. And those will be different everywhere. But again, I think fundamentally you have to have some notion of a framework. There's lots of tools that allow you to do that. And you kind of pick and choose what you want, but it should be a conscious decision, not something that just sort of evolves by user choice.
But that implies that there might be tools that could assess something that does come from the internet, from another community, and if in fact it passes the muster, then that's okay? On security?
It's okay until you find out that it's not okay, and then you fix it.
Okay. Dave, something to add?
So, this is not a new problem. We've been using open source software in the Department of Defense and national security community for years. I agree with everything that's been said by my colleagues. We use open source software from primarily supported from reputable vendors who've gone through security certification criteria. When we do bring novel code in, we do not only use code analysis tools, static analysis tools, but we do testing on that, penetration testing, code reviews, etc. But I don't think that this is a new problem. I think it is a problem that we've been dealing with for several years, and perhaps not even a problem. It's an opportunity, and we like the opportunity, and we like the partnership of vendors who are willing to support open source software and ensure that that build that they're basing their product on is secure, reliable, and robust.
Tracy?
I think I agree with everything that's been said so far. The one area that hasn't been touched on is everything that they've said about software also applies to infrastructure. If you don't have supply chain assurance, as an example, on your infrastructure, it doesn't really matter how well your hardware or how well your software is protected if your BIOS is leaking information where you don't want it to go. So we're investing significant time, effort, and money in making sure that we have a secure supply chain from original component supplier all the way to delivery to our customers.
The Defense Authorization Act, I think, of 2014 put in that whole issue about supply chain assurance. I know that's a big issue for the DoD. Well, all of this really is painting a very different thought process and cultural environment for developing software and developing applications than people might have grown up with. So let's start with Naveen. What are some ways you prepare an organization for this new world of that we've been talking about?
So I think that there's as much culture change here as there is technology change. And one of the ways that we really have to look to shift ourselves towards actually being able to employ the cloud well and securely and rapidly, right? Is to step back and reassess our assumptions about where our risks lie, right? So if I an example, right, is the cloud a capital expense that should be thought of? Should we be filling out those 20-page forms every single time we want to launch a new server on our infrastructure as a service capability? Probably not, right? Because the amount of time that you're going to spend doing that is going to cost you more than the risk that you actually would incur by launching the wrong service for a week or two, right? Or whatever it might be, right? So the risks start shifting so that we start looking to really understand how we go away from let's worry about everything that we're doing up front to one where we spread that planning and that activity throughout the course of actual implementation and start showing product and progress rapidly.
All right, and in the last 20 seconds that we have, Charlie, I'll ask you, sound right to you in the NSA?
Sure. Again, we've focused pretty heavily. I think the cultural challenges are some of the biggest ones that we face. We focus pretty heavily on trying to get some mission effects really quick with this, and one of the approaches we've taken is by kind of pairing up our developers with analysts that have a problem that needs to be solved, and that's been implemented in something we call our Cloud Analytic Fusion environment, or iCafe. That's been very effective for us. It's allowed, again, almost instant kind of gratification.
All right, lots of questions, lots more we could explore, but unfortunately we are at the end of our clock. I want to thank today's guests. Charlie Bradley is the Technical Director for the NSA's Technology Directorate. Dave Mihelcik is Chief Technology Officer at the Defense Information Systems Agency. Dr. Naveen Vembar, Cloud Engineer and Director of the GSA IT Integrated Award Environment. Nathan Jones, Vice President of Federal for Red Hat. And Tracy Pavillard, Executive Director for Dell Federal. I'm Tom Temin, federalnewsradio.com and 1500 AM.
On behalf of Red Hat and Dell Federal, thank you for joining our discussion. We'll have the archive from this session available shortly, and a link will be sent to you to share with your colleagues. Those of you who requested a training certificate will receive an email with download instructions immediately following the webinar. This concludes today's webinar. Thank you.